Okay, so in this video, we're going to be looking at multiplying polynomial expressions. And one of the things we are going to be talking about multiplying is the fact that we're always going to distribute, which means that you multiply each term by each term. So here, the 3x is going to multiply to x squared, and it's going to multiply by 2. So I have 3x times x, and I have 3x times 2. But notice that now I'm dealing with both numbers and variables. I'm sorry, that should have been 3x squared. I'm dealing with both the numbers, coefficients, and variables that have exponents. So because we are multiplying, the first thing that we're actually going to do is multiply the coefficients together. So here my coefficient is 3 and 1, that's just 3. Here my coefficients are 3 and 2, and that is 6. But I now have to wonder, well, what do I do with my x's? We're not combining like terms at this point. It's okay that they're different because we're multiplying. If we go back to our exponent rules, it says when you are multiplying things with the same base, we add their exponents. So x to the 1 and x squared gives me x cubed. Here I only had one x, and so it just gives me x. So this whole expression would be equal to 3x cubed plus 6x. So we multiply those coefficients each time and we add the exponents each time. So this one was a basic one with just a monomial by a binomial. Often they're slightly larger. And so I'm going to demonstrate to you guys actually what I call the box method. This was the arrow method, was showing that I did it to this term, and then I distributed to the next term. So the arrows kind of help you just show that you're actually going each time. But the box is a lot easier to organize. So with the box, what we're going to do, first off, draw a box. We then write our first polynomial on the top, so it's 3x and it's 2. For every term, go ahead and split it down. Now x and 1, those are going to go into the side. What we're really doing is we are finding the area of each of these boxes by multiplying the length times the width. So for this one, it's going to be 3x times x. Well, that gives me 3x squared. For this one, it's going to be 2. Here, well, this is the same as this. It's x. 2 times x gives me 2x. 3x times 1 gives me 3x. And then 2 times 1 gives me 2. The reason I like this method is because you see this last step here is to then add. We have to combine the like terms. If both of your factors were given to you in standard form, or you rewrote them in standard form, then your like terms will always be diagonal to each other. So here, 3x squared doesn't have anything else. It's just 3x squared. Here, 3x and 2x are like terms. They're diagonal to each other. So that's 5x. And then 2 is just 2. So let's do that again with one that is slightly larger. So notice here, these are not written in standard form yet. So when I make my box, I'm going to want to put them into standard form. It's going to be a trinomial by a binomial. So I like putting the larger one on top. It doesn't actually matter. So I'm going to rewrite this into standard form. 5x squared minus 7x plus 4. I'm going to rewrite the other one in standard form going down, 2x and 3. We multiply each of our boxes together here. So 5x and 2x gives me 10x squared. Negative 7x and 2, negative 7 and 2 is negative 14. X and x is x squared. 4 and 2 is 8, and then bring that x. Here, 5 and 3 is 15 with that x squared. Negative 7 and 3 is negative 21 with that x. And then 4 and 3 gives me 12. Once again, I'm going to be looking for those like terms. 10x squared is just 10x squared. 15x and 14x are diagonal, so 15 minus 14 is 1. Sorry, that first term should be cubed. I was just looking at that x squared and x to give me an x cubed. I apologize for that mistake. Hopefully you caught along with me. Moving on to the next one, I have 8x and negative 21x. Once again, they're diagonal to each other. Negative 21 plus 8 is negative 13x, leaving me with my last one here of just 12. Doesn't have anything else to go with it, so it is just 12. So this is how we can multiply. And using this multiplication box, when we move into division later on, we can actually use the same box to help us divide out, which is pretty cool. So there you have it, multiplying polynomials.